Hey folks, Mr. Dell here. We are looking at changing numbers in decimal form to fraction form and reviewing that concept. So this is coming from section, uh, actually it's CPM, first tell you this, CPM course 3, section 10.1.1, specifically number 10-15. So it says change each number below from a decimal to an equivalent fraction. For help with repeating decimals, review the math notes. Well, I'll go through that and re-explain that. So here we have a terminating decimal, right? That doesn't repeat, it just terminates. So if we look at this number, the easiest way to consider it as a fraction is to know your place value, right? So you have the tenths and hundredths. So this would be read as 72 hundredths. So 72 over 100, 72 hundredths. So that's one way of looking at a terminating decimal and reading it as it's supposed to be read, 72 hundredths, knowing that means 72 over 100, 72 hundredths. The other way to consider it is knowing how many decimal places there are. So there's two digits after the decimal. Therefore, your denominator will have two zeros. It's always going to be either a 1, a 10, a 100, a 1,000, 10,000, and your number of zeros is determined by how many digits after the decimal. Okay. So that being said, if we go over to C, I'm going to count. I've got 1, 2, 3 digits after the decimal. So my denominator will have 1, 2, 3 zeros. And then my numerator is those digits. Okay. And again, how would I, if I went back the other way and I think, how do I read this? This is 175 thousandths because that's the thousandths. That 5 is in the thousandths place. So that's why it's written that way. All right. Now, each of these fractions here, we could also simplify, right? We could actually simplify these fractions by dividing out. In this case, I can divide out a 4, a giant 1 of 4, right? You're dividing top and bottom by 4, and you would get, let's see, that's 1, 8, no, that's 1, yeah, 18. So that is 18 over 20, oops, 25. So 18/25 would be the also the fraction equivalent. This one I can divide out top and bottom 25, and it divides 25. So 25 goes into 175 7 times. 25 goes into 1,000 40 times. So that's the also the fraction equivalent of 17 175 thousandths. All right. Now these two are repeating. The thing about repeating decimals is repeating decimals always have at first a denominator of digits of 9. So, for example, I'm just going to remind you. So if I said point 2 repeating, well, that's one digit. So this is actually 2 ninths. So there's a digit of 9 in the denominator. So 2 divided by 9 is 0.2 repeating. Okay. So over here, there's two digits that are repeating. So we would say that's 72 over 99. Okay. So 72 over 99, which we can actually simplify this. It looks like 9 divides into each of them. I can divide by 9, the giant one of 9, and that gives me 8 elevenths. So the 8 elevenths is the same thing as 72 99ths. And if I showed you I could divide this 8 by 11, I'm going to get 0.72 repeating. Last one, this has got 1, 2, 3 digits being repeated. And so it would be 175 on the top. And on the bottom, it'd have a denominator of 999, 999. So nice way to think about it is when it's not repeating, when it's terminating, your denominator is a multiple of 10, right? Because, and then depending on the zeros, how many zeros, right? Two digits, two zeros, multiple of 10, that's 100. Three digits, three zeros, multiple of 10 is 1,000. Here, we have multiples of 9, or actually just digits of 9. So 999, 999, 999. So that's how we determine fractions, based on repeating or terminating from a decimal. Okay, there we go.